Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this couple of videos we are going to take a detour from pandas and talk about basic descriptive statistics. And the reason for this is that in coming videos, when we start using some of these statistical methods in the code, you'll be able to interpret what the output is, and you'll have an intuition about what's probably happening in the background when the code ran to give you that particular output. So here in this couple of videos, we're going to talk about all these topics that are put here on this slide, starting with what is population and sampling statistics, and then what is histogram, mean, standard deviation, all the way up to geometric mean and harmonic mean. So there's a lot of stuff in here, and I tried to make one video, but it was more than an hour, so I've broken that up into multiple videos, and in each of those videos you'll see parts of this being discussed. So I hope you learn from these videos. So let's get started. One concept of distribution which you'll use frequently is skew. So the very first initial slides that you saw, the distribution of the 1000 data points that we had, it was a nice bell-shaped curve. However, in this case, what we see is a data that is skewed. Skewed means it is not uniformly distributed as we had it before. In this case, most of the data points are on the left hand side of this plot, and there is this tail on the right hand side. This line, this part of the plot where there are very few readings, and this curve kind of looks like it's a tail, and therefore this is called as the tail. So, and this here is also called as a skew. So the data is skewed towards the right hand side. So most of the data is shifted, skewed to the right. So most of the data is shifted to the left. So the skew is on the right hand side. You see, it's kind of extended or pulled on the right hand side, very few data points. And this skew is also towards the positive direction of the x-axis. It's moving away from the 0, and therefore it's also called positive skew. If you calculate skew, we'll see how to do that in coding as well. So it's positive skew. That tells us that the tail is on the right hand side. Similar to positive, there is a negative skew. Here most of the data point lie on this right hand side, and the tail is on the left hand side. So tail is towards left hand side towards 0. It's moving towards the negative direction of the x-axis, and hence it's also called a negative skew. And if you calculate the value for skew, it would be minus, and therefore it's minus 1.26 for this particular data that is plotted. So that is skew, and you'll see that in data sets where, let's say, if you are trying to find how long people watch a particular channel when they turn on a TV, and it's more likely that you'll see something like here, positive skew. Most people watch for maybe 10 minutes and then drop off, so they change the channel after 10 minutes. So that's what you'll see in a positive skew. Now to calculate skew, we are going to use the same data set that we had earlier. We have these 7 data points. We calculate the mean and standard deviation. Then, as shown in these two columns, we calculate the difference between the battery life observation and the mean. So 11 minus 47.86, we get minus 36.86, and so on and so forth. And then we divide this difference by standard deviation. So minus 36.86 divided by 26.93, we get minus 1.37, and we do that for all the observations. Next, we are going to take a cube of what we calculated here, and the cube of minus 1.37 would be minus 2.56, and so on for all other observations, and then we sum them to get final value of 2.55. Then we are going to put this value of 2.55 in this formula here, where sum C is 2.55, and then for D we are going to get that value from this formula up here, which is n divided by n minus 1, n minus 2, and that is 0.233, and thus we get a skew of 0.944. so it's a positive skew, and so that's what we can get from this particular calculation. Next, let's look at kurtosis. So kurtosis, again similar to skew, it helps us identify what's going on with the shape of the data set. So here we have a plot where we have three curves, three data sets plotted on top of each other. Now the one in the green is what we would normally expect the data should look like, which is a nice bell-shaped curve, and that in this case has a kurtosis value around 3, which is 2.9, that's close to 3, and that is called as mesokurtic. Next, we see this blue curve, which is a little pointed, and it has a larger height, and it's kind of narrower tails on either side, so that is called as a leptokurtic data set, and the kurtosis value for that type of distribution would be greater than 3. In this case it is plus 4.76. Next, there is another type which is platykurtic, which is shown here by the orange curve, and that data set, the distribution is much wider and it has much heavier tails as compared to other ones. In this case, we can see that it's more flatter curve as compared to the other two curves. And if you look at the kurtosis value for this type of kurtosis, it's less than 3. In this case, it's minus 0.32. Now, to calculate the kurtosis, again, this is a messy formula as you can see here, but this is just to show you how it is done, what happens in the background. If you calculate it in Python, it's really easy. So let's go through the calculation. Here we have the same data points, 7 data points. Now, to calculate kurtosis, what we are going to do is create 4 columns. First column, we exponentiate it by 1, or we can say we just have that value as is here. The second one is x squared, so x to the power 2, and so this is 11 power 2 is 121, same here. And then here we have x to the power 3, x to the power 4. Then we take sum of all those columns, which are s1, s2, s3. Then we put these values of s1, s2, s3 in these formulas that are below here to calculate k2 and calculate k4, where n is 7, which is 7 observations. And after you go through this, we want to put that in this formula, which is k4 divided by k2 squared. And when you do that, we get a kurtosis value of 0.45, and that is less than 3. So we could think of this as a platykurtic distribution. That was it for this video. In next video, we'll continue learning more about statistics. Please like, share and subscribe. Thank you.